Hello and welcome to part 3 of chapter 2 differentiation techniques. So in this particular video, we will be talking about the basic differentiation formulas. Now is the exciting part because what we're going to do is to use or to find the derivative of a function using the formula. Okay. So first, you can include these formula to your cheat sheets because we're going to use them later on. Okay, so we have the basic differentiation formula number 1, the derivative of a constant. If C is any real number, take note, meaning to say that C is a constant, then we have d all over dx of C is equal to 0. Okay, and of course, we're going to show the proof. Kailangan natin ng proof because when you apply for a teaching position and you were assigned at the senior high school department, STEM, so probably you might teach calculus, basic calculus. You need to show to your students how these formulas were derived. Okay, so let's show the proof. Okay, let's prove that d all over dx of C is equal to 0. Okay, so basically we let f of x, okay, f of x be equal to C. Okay, then by the definition, of the derivative that we talked about in the previous video, we have that f prime of x, okay, f prime of x. So I can just write this one as d over dx of f of x. Okay, but yeah, just the same notation. Or f prime of x, it will do, is equal to the limit of f of x plus h minus f of x. Sorry. This one is f of x over h as h approaches 0. Okay. Now, so we know that C is a constant. So since C is a constant, then we can just rewrite or rename C as a sum of two constant numbers as well. So we can say that C be equal to x plus h. Okay. So therefore, we can say that we have the limit of f of C, okay, minus, we have here f of C all over h as h approaches 0. Okay, and in that case, we know that this is just the limit of C minus C all over h as h approaches 0, which implies that we have here the limit of 0 all over h as h approaches 0, implying that we have here the limit of 0 as h approaches 0, which is actually 0. And therefore, our theorem holds. Okay? Next, the basic differentiation formula number 2, the derivative of a function x. So, by the way, before we proceed, we know that if f of x is a constant function, f of x is c, meaning to say this one is a constant function. Constant function, okay? So if this one is a constant function, then definitely the slope is 0. Kasi di ba kapag ginraph niyo yung constant function, it is just a straight line, horizontal line, correct? So therefore, it has no slope. So therefore, the derivative is equal to 0. I hope that you can follow. So if x is a differentiable function, then d over dx of x is equal to 1. Okay, the derivative of the function x is equal to 1. And again, let's prove that. Okay, need to show that the derivative of x is equal to 1. Okay, nag-prepare ako actually. So we have the proof. So we let f of x be equal to 1, rather x. Okay. Then, okay, by definition, d over dx of f of x is equal to the limit of f of x plus h minus f of x. So you see that the definition of the derivative is useful, especially in showing that the formulas are true as h approaches 0. Okay, so this implies that what I have is the limit of f of x plus f of h, I just distributed it, minus f of x all over h. Okay, as h approaches 0. And we can cancel out f of x already because it is 0. What we have is the limit of f of h all over h as h approaches 0. But we know that f of h is just h, correct? So this becomes h all over h as h approaches 0. So what I have is the limit of 1 as h approaches 0. And we know that the limit of a constant is the constant itself. So this is 1. Okay? So therefore, the theorem holds. Okay? Next, we have the basic differentiation formula number 3, the derivative of a constant and a function. Yung other books, they say that it's constant times a function. It's just the same. So if we have, if u is a differentiable function of x, then the d over dx of c times u is equal to c times d over dx of u. Okay? And again, we're going to show that. Let's have the proof. So let u be equal to f of x. Okay? Then we have d all over dx of f of x is just the same. I will be using the definition, the limit of f of x plus h minus f of x all over h as h approaches 0, then it will be equal to, since we have a constant c, then what we have is the limit of c times f of x plus h minus c times f of x. Okay? Because that's a constant times a function, which is over h as h implies 0. Notice that the common factor is c, that I'm going to get the common factor. So we have the limit of constant times f of x plus h minus f of x all over h. And since we have as h approaches 0, and since we have a constant here, yung limit of a constant times a function suggests that we can transfer c before the limit, getting the limit of the function. Okay, so this becomes c times the limit of f of x plus h minus f of x all over h, okay, as h approaches 0. Okay, but we know that this part, take note, this part po, itong part na po na ito ay just ito lang nasa taas natin, which is ito. Okay, so I can just substitute or rewrite it as something like that. So what will I have is c times d all over dx times f of x. Okay, and we know that f of x is equal to u, so that I have is c times du all over dx. Okay, and we're able to show that it holds. Next, we have the derivative of a sum or difference. Okay, pwedeng difference dito, pwedeng sum, but in general, it's always sum. So if we have two functions, differentiable functions of x, that is u and v, they are differentiable functions of x, then the derivative of u plus v in terms of x is equal to du over dx plus dv all over dx. Or sometimes, pag may minus dito, syempre minus din dito sa kabila. Okay, let's prove that. So again, let's have a representation. So let u be equal to f of x and g and b rather be equal to g of x. Then we have the derivative of f of x plus g of x can be in terms of what? This is the limit of syempre f of x plus h plus g of x plus h, okay, minus this is f of x plus g of x all over h as h approaches 0. Okay, then let's simplify the expressions in the numerator. We have the limit of f of x plus h plus g of x plus h minus f of x minus g of x all over h. Okay, as h approaches 0. So I can just regroup the terms which are of the same kind, similar terms, sinasabi natin, in terms of x and in terms of the function f of x and in terms of the function g of x. We have the limit of f of x plus h minus f of x, okay, plus g of x plus h minus g of x all over h. as h approaches 0 is equal to, okay, since this one is a fraction, recall that I have to put a grouping symbol so that we can separate the terms. Okay, so recall, mag-recall tayo. Since the numerator is a binomial and we have a monomial denominator, then we can separate it. Okay, so recall that whenever we have a plus b all over c, then it is a all over c plus b all over c, provided that c is not equal to 0. Okay, so what we have is the limit of f of x plus h minus f of x all over h, okay, plus g of x plus h minus g of x all over h, okay, as h approaches 0. Then applying the limit of sums, what I have is the limit of f of x plus h, okay, minus f of x all over h, and this one is h over, as h approaches 0, plus the limit of g of x plus h minus g of x as a over h as h approaches 0. So we know that the first term is just written as d over dx of f of x. Okay. Then plus this one is d over dx of g of x. Which implies that what we have is du all over dx plus dv all over dx. Okay, and this ends our proof. Okay, next, finally is the derivative of a power. The derivative of a power. So that one is quite tough. Okay. So if n is a positive integer, take note that n belongs to the set of positive integers. Then d over dx of the function x to the n power is equal to n times x raised by n minus 1. So anong nangyari dito? Yung exponent ng x, which is n, minultiply lang natin siya dito sa kanyang numerical coefficient, which is 1. And then nagbawas lang tayo ng isa sa exponent. Kaya yan ang iyo pong papalatandaan kapag dating sa differential calculus. Nagsusubtract tayo ng isa sa kanyang exponent. Doon naman sa integral calculus, sasabihin ko sa inyo advance, mag-a-add naman tayo ng isang exponent. Okay? Sa diffcal, minus 1 ang exponent. Sa integral, plus 1 ang exponent. So let's show the proof of this theorem. Okay? So again, let's show the proof. What we need to show is that the derivative of x to the n power is n times x raised by n minus 1. Okay? So, and take note again that n here belongs to the set of positive integers. Okay. So, we let Okay. Let U be equal to f of x. Where n belongs to the set of positive integers. Then, by definition, the derivative of the function f of x is the limit of the function f of x plus h raised to the nth power minus f of x raised to the nth power all over h. Okay? As h approaches 0. Which implies that we have what? This is the limit of x plus h to the nth power minus x to the nth power all over h as h approaches 0. So what can we do is, so since this one is a binomial, so what we're going to do is to use, okay, using the binomial theorem. Okay, binomial theorem. I hope that you have studied this one in your number theory class. So, recall ha, recall tayo ng binomial theorem. We have a plus b raised by the nth power. Then, what we do have is the summation of nk, okay, from k is equal to 0 up to n is a raised by n minus k multiplied by b raised by k. This is our formula, okay, which is okay, where nk, okay, nk is equal to, this is just a combination formula. We have n factorial all over n minus k factorial k factorial, di ba? Yan yung formula natin. Which implies that when we expand this formula, what we have is n0, okay, the first term. We have here a raised by n minus 0, b to the 0 power plus n1. We have a raised by n minus 1 times b raised by the first power plus blah, 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 plus what we have here up to n. Then, dumating yung point of time that n, that k is equal to n. What we have is a raised by n minus n and b to the n. Okay? So, mahaba-haba ito eh. Let a be equal to x and b be equal to h. Then, what we're going to do is we have the limit of x plus h to the n power minus x to the n power all over h. As h approaches 0 implies that we have, applying the binomial theorem dito sa first term natin, what we have there is what? We have n0 here. Okay. We have x raised by n. Then we have h raised by 0. Okay, plus what we have is n1 tayo dyan sa k. So what we have here is x raised by n minus 1, h raised by the first power plus up to plus. Okay, we have here n, parating tayo sa n, wherein we have here x raised by n minus n and h is raised by n. Okay, that's the first term pa lang yan, first term. Okay, minus x to the n power. So notice that what we have expanded is the first term using the binomial theorem. All over h. Lagay ko dito yung limit ha. Limit as h approaches 0. Okay? So let's expand this further. So this implies that we have what? The limit. Lagay ko na yung limit, hindi ko makalimutan. Let us expand n0. Oh, dito to be what? N factorial all over n minus 0 factorial. Then we have 0 factorial. Okay? And then we have here x to the n power plus, we know that h to the 0 is already 0. Using ko ngayon n para maganda. Okay, plus we have here n factorial is n minus 1 factor, n times n minus 1 factorial. Okay, all over n minus 1 factorial 1 factorial. Okay, I have here x raised by n minus 1 h plus blah 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 plus saan na ako? N factorial. N factorial all over n minus n factorial, n factorial, then I have here h to the n power. Okay? Because x raised by n minus n is x to the 0, that's already 1. Okay. Then I have here x to the n power all over h as h approaches 0. Okay. So this implies that we have what? So this is already 1 n factorial. N factorial over n factorial is 1. And we know that 0 factorial is equal to 1. Okay? O recall ha, recall. 0 factorial is equal to 1. So this one is 1 already. So what I have is the limit of x to the n power na lang ako dyan. Okay? Plus, may matitira ako dito sa taas, sa kabila. Which is, I can cancel out n factorial here. Magiging 1 na lang yan, di ba? So magiging, mayroon ako ditong n times x raised by n minus 1. Then I have h here. Okay. Plus, blah, 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 plus, what I have here is h to the n power. Because this is already equal to 1. Okay. 0 factorial is 1. So 1. H to the n power. I have here h to the n power. Okay. Minus x to the n. All over h. As h approaches 0. Okay. So I can cancel out x to the n power. And what I have here is n times x raised by n minus 1 times h plus h, blah, blah, blah. And notice that I can get the common factor, which is h. So what I have is the limit of h times, what I do have there is n times x raised by n minus 1 plus blah, 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 plus h raised by n minus 1. Okay? H raised by n minus 1 all over h as h approaches 0. Okay? I can cancel out h. And what I have is, this implies that I have the limit of n times x raised by n minus 1 plus up to h raised by n minus 1. But we know that h approaches 0. So whenever h approaches 0, we know that h raised by n minus 1 and all the terms aside from the first term is equal to 0. Diba? So therefore, we're able to show that we have n times x raised by n minus 1. Okay? QED. So this is the derivative. Ayusin ko ito. The derivative of the function f of x. Okay? So that is how you derive the formula, the 5 formulas. Meron pa tayong dalawa ha. Later on, I will discuss that. But let's apply these 5 formulas to our example. Okay? So example 2.1, find the derivative of the following functions. Okay, for number 1, so we have the solution. Ilalagay ko dito kung anong formula ha, kasi para maintindihan ninyo. So step by step. Pero kapag dumating yung time na kabisado nyo na kahit hindi nyo siya step by step, diretsahan na, okay lang din sa akin. But since you are beginners, syempre step by step muna. So number 1, we have f of x is equal to 3x to the 8th power a plus 2x plus 1. So f prime of x, pareho lang naman yan, di ba? This is 3 times d all over dx, x to the 8th power, minus 2 times d all over dx of x, a plus d all over dx of 1. So this is actually basic differentiation formula numbers. We have 3 and 4 respectively, respectively, kung ano yung pagkakasunod-sunod niyan. Next, so this is 3 times, mag-multiply ako dito. So this is 8 x raise it by n minus, that is 8, that is x. Lagay ko this is 8 minus 1 minus 2 times 1 plus 0. Okay, so this is basic differentiation formula number 5, 2, and 1 in that order. Okay, in that order. So to simplify this is 3 times, we have 8x to the 7th power minus 2. And to further simplify it, we have the f prime of x, is equal to 24 x to the 7th power minus 6. And this is the final answer. Okay? Plus pala to. Sorry, wait lang. Nabubulag ako. So, puro plus to. Okay. Next, we have number 2. For number 2, we have f of x is equal to negative 1/3 of x to the 7th plus 2x minus 9. Then f prime of x would be negative 1/3. Okay. D all over dx. Times x squared plus 2x minus 9. Okay, isa lang to. This is basic differentiation formula number 3. Okay. Then, negative 1/3. This is d all over dx of x squared plus 2 times d all over dx of x minus d all over dx of 9. This is basic differentiation formula number 4 and 3 in that order. Okay. Next, we have here negative 1/3 times, we have here 2 x raised it by 2 minus 1 plus 2 times 1 minus 0. So this is basic differentiation formula number 5, 2, and 1 in that order. Let's simplify the expression. What we have is negative 1/3 times, I have here 2x, okay, 2x plus 2, okay, 2x plus 2. Ay, sorry, ano pala siya to the 7, sorry, it's the 7 power. Bakit 2 ang to the 6 pala yan. Kamukha kasi ng 2 ko eh. 7, 7. So this one is 7 minus 1. 2 to the 6th power. So this one is 7. Seven. 7x to the 6th power. Okay? So, i-multiply nyo na lang yan. Ang lalabas dyan ay, of course, we know that's negative 7x to the 6th power plus 2 all over 3. Or you can write it something like negative 7 over 3x to the 6th power minus 2/3. Pareho lang yan. Okay? And for our number 3, we have f of x is equal to x squared plus 1 all over 5 at x is equal to 1. Okay, so we have f prime of x is equal to, this is just 1/5 times x squared plus 1. So I'll be writing it as 1/5 times the derivative of x squared plus 1. Okay, so at x is equal to 1. O, ito po yung x naught. Okay, so I have here 1/5 of d all over dx of x squared, dandaan ko pa rin ha, plus d all over dx of 1, okay, at x is equal to 1, then what we have here is 1/5 of, this is 2x raised it by 2 minus 1 plus 0, okay, at x is equal to 1. Then what I have here is 1/5 of 2x, okay, which is, to simplify that, that is f prime of x is 2x all over 5, okay, but this is not yet the story because we need to evaluate it at x is equal to 1, okay, so that is f prime of 1 is 2 times 1 all over 5 is f prime of 1 is 2 all over 5. Okay, and this is the answer. Okay, so I'm going to cut this video. I'm going to see you in the next video.